So hello, good afternoon to all of you. Let's start the today's class. As in yesterday class, we have discussed about some basic fundamental of the oscillations. I hope my audio and video is clear. If my audio and video is clear and screen is visible, so please give me a message in comment box. Please ensure that everything is clear. I hope I am audible. Rahul. Okay, thank you so much. So let's start the class. What we discussed in yesterday class, just take a brief look. We discuss about the periodic motion, what is the periodic motion, what is the oscillatory motion, how oscillatory motion is the part of the periodic motion, and which type of some important characteristics which makes SHM is a type of oscillatory motion. Okay, we know that not all oscillation is SHM. For a given oscillation where value of n equal to 1 and amplitude is small, such type of to and fro motion, that is oscillatory motion, is known as the simple harmonic motion. I hope. And what is happening in the periodic motion? Every oscillatory motion where a total mechanical energy is conserved comes under the category of periodic motion. In periodic motion, there are two types of motion is possible. One is the circular motion, where direction of sense of motion is not going to be changed, and another is the oscillatory motion, where the motion direction is changed after a regular interval of time, such as to and fro motion, and that kind of motion is known as the oscillatory motion. So I hope it is clear to everyone, and we just discussed what is the kinematics of SHM. Whenever I am talking about the kinematics, so we interested to discuss about what is the displacement of particle, what is the velocity of particle, what is the acceleration of the particle. In other way, we can say we want to discuss about the motions parameter, how motions parameter that reflected in SHM, and what is the importance graph of this motion parameter with position, with time also. Okay, so I hope this is clear to everyone, and I want to write down some important equation that we derived in yesterday class. Okay, anybody can tell me what is the equation of displacement of particle, that x equal to a sin omega t plus phi. Okay, beta, we have to clear about every single terminology that involved in this equation. We have to know that, sir, what is x here? What is x here? We have to know, sir, how x is defined and what is x. So we can say that, beta, our x is nothing but our x is the displacement of the particle. Okay. What is a? That is the amplitude. What is the omega, beta? Omega is a specific type of term that is defined under root k by n. We take our assumption in the equation of acceleration, where we derived all the equations, that omega that is defined as under root k by m is angular frequency of acceleration, and this phi is known as the initial phase, and this phi value describe about where is our particle at t equal to 0. So what is physical importance of phi? Sir, phi tells about at t equal to 0, what is the position of particle. I hope it is clear to everyone. What is the importance of this phi? This phi tells about initial position of particle. What, beta? Initial position of particle. It means we know that our particle will perform simple harmonic motion between two extreme position, if we can say that the left stream to right stream. So there are infinite numbers of positions that are possible here. What is the exact position of particle from where particle will start its motion? That is described by the phi, that is the initial position of particle. It tells about the initial position of particle, and this is known as beta initial phase. Initial phase. And this complete omega t plus phi is known as the phase angle. Phase angle. Okay. And we already know what is the equation of velocity of particle. What is the equation of velocity of particle? So how we can find out the value of velocity? Just differentiate this equation, and we know the equation will a omega cos omega t plus phi. I hope this is clear to everyone. And in order to find out the acceleration, further we have to differentiate, because we know the sequence. If displacement is known, then how we can calculate the acceleration? Everybody, x, if we know the value of x, we can easily calculate velocity and then acceleration after differentiating the equation in order to, after finding the slope of xt graph. Okay, beta? If we find the slope of xt graph, we get velocity. When again we find out the slope of vt graph, we will get the value of acceleration. So in order to get the value of acceleration, again we differentiate this equation, and we know that this is the simple differentiation, that minus a omega square again sine omega t plus phi. Better listen here. This is the equations of motion parameter in terms of time. We know that basically there are two types of variable. One is time dependent and another is position dependent. So here we define the motion parameter as a function of time only. If we want to write down these equations in terms of position, so anybody in this class, can you tell me, in yesterday class we just derive a very beautiful equation of velocity of particle in terms of position of particle. So beta, what is the velocity of particle? V equal to, we know that is the V equal to, we already know what is this value, that omega under root a square minus x square. Am I correct, beta? Yes or no? This is the equation. If you want to see where we derive this equation, so we derive this equation by basic fundamental kinematics equation. You can see here, okay? And this is the velocity of particle at a given position x. Okay, if we want to show with the help of a diagram, see here, we suppose that this is the left stream position, x equal to minus a, right stream position, x equal to plus a, and say this is the mean position, x equal to 0. So there are multiple positions possible. Okay, and we can say that for a given time, a particle will start its motion from any point. Okay, so if we consider that, suppose this is the time t equal to 0, and if we want to know what is the velocity of particle at this position, so how we can tell? How we can tell? We just tell what is the displacement of particle from mean position. Suppose if this position is a by 2. So can you tell me what is the velocity of particle at x equal to a by 2? We just put value of x equal to a by 2 and we will get answer. I hope this is clear. And what is the maximum value? There are some important formula that I am writing in this slide. You have to note down whatever you want. You can also take a screenshot. Okay, beta? In order to find out the maximum velocity, anybody ask to you at which point in SHM particle will attain its maximum velocity, then what is your answer, beta? Sir, mean position. Why, sir? Why, sir? Sir, at mean position, velocity and acceleration acting in same direction. It means speed is maximum. And another method to recall this, because at mean position, particle is at equilibrium, it means it is stable equilibrium. So for stable equilibrium, potential energy must be minimum. And we know that if the total mechanical energy is conserved, then kinetic energy must be maximum. And kinetic energy is maximum, then speed will also maximum. So where this will happen, beta? At x equal to 0. So what is the maximum value, beta? Plus omega. In the same manner, if you want to find out the acceleration, we already know, beta, that is omega square x. And what is the maximum value of acceleration, sir? This will occur at extreme position because a is proportional to x, that minus omega square e. In order to find out the magnitude, you can write down. Okay. So, beta, what I want to convey with you, these are the some basic characteristics, equations. By using these equations, we will solve multiple types of problem. Let me see in next slide how we can solve different category of problem involving kinematics. Okay, so let's start a simple problem. If you solve this problem, so there is no need to do there are 100 types of problem. Okay, because in a single problem, all the possible questions that can be formed in kinematics, I already taken. Okay, so let's solve the given problem. First of all, this problem help to strengthen our basic concept. In the particular problem, beta, what is given? Sir, it is given that equation of SHM is given. Okay, whenever equation of SHM is given, what is our first task? What is our first task? Just compare the given equation, your standard equation. What is our standard equation, sir? That x equal to a sin omega t plus phi. Are yes ya no, मेरे लाल? Yes ya no? Yes ya no? Please, you can chat in comment box. Whatever problem you are facing, if there are some doubts, you can mention in comment box. Okay, okay, beta ji. Sir, if we compare this equation, then in first side we can clearly say that sir, amplitude is nothing but that is 2 meter. So what is the value of amplitude? By equating to equation, by given equation, if we compare our standard equation, we can say, sir, this is the 2 meter. I hope this is clear to everyone. What is angular frequency? What is angular frequency? Sir, this omega is known as angular frequency. And here it is very clear that omega is nothing but 2 pi. Omega is nothing but 2 pi. Okay. What is unit of omega, beta? Radian per second. Okay. So what is value of omega? That 2 pi radian per second. Okay. Can anybody tell me what is the value of time period? Beta, in order to find out the time period, we must know some basic relation between the angular frequency and time period. Our mechanics. Okay, we know that in mechanics, what is the time period? Sir, we know that if a particle is completing circular motion and it will take t time to complete its motion. It will take t time. Then what is time? Time is nothing but beta total angular displacement divide over what is the speed of particle. That time is nothing but distance upon speed. What is speed? The particle possesses a constant angular speed. Say that is omega. That is known as here angular frequency. So here we establish a very important relation that time period is nothing but 2 pi upon omega. And we know that ki beta omega, here if we want to write down the time period is also inversely proportional to frequency also. That frequency is linear frequency. So we can also write down this equation ki omega is nothing but, sir, omega can be write down 2 pi f also. Is such type of basic formula we already know from our circular motion chapter. So once we get the value of time period, what we can write down here, beta? 2 pi upon omega. What is the value of omega? 2 pi. So what is answer, beta? That is 1 second. I hope in three part everybody is comfortable. Okay, if everybody is feeling comfortable, please send me a thumbs up in comment box. Okay. Then we move for the next part. If you are comfortable in these particular three portion, please comment beta. Please comment in chat box if everything is clear. All three parts are clear to everyone. How we can calculate? Okay, because it is necessary to all students. We can understand each and every concept in order to strong our advanced level concept. What is maximum velocity? Sir, in the previous slide, we know that the maximum velocity is nothing but that is A into omega. Are yes, ya no, beta ji. What is amplitude? Sir, we already know now 2. What is omega, sir? Omega, we already know 2 pi. What is the unit of velocity? Sir, SI unit 2 meter per second. Then what is answer, beta? 4 pi meter per second. I hope it is clear to everyone. What is the maximum acceleration? Whenever it is talk about the maximum acceleration, we have to only write down magnitude, and we already derived in the previous section that is nothing but beta omega square A. So we put the value of just omega, that will equal to 4 pi square into amplitude, and this value will become beta. This value will become 8 pi square. And what is the unit of acceleration? Meter per second square. I hope this is clear to everyone. That is the next portion. What is the initial position? What is the meaning of this? What is the meaning of initial position? It means I would like to know at t equal to 0, what is the exact position of the particle. Then how we can get the value of position? Sir, from the equation of position, equation of displacement. If we want to find out the value of initial position, put t equal to 0 here. Once we put t equal to 0 here, what we will get from this equation? Say this is the equation number 1. We can say this equation will become x naught. X naught means position of particle at t equal to 0. We can write down that 2. T equal to 0, if we put here, this will become sine pi by 3. And I hope everybody know beta what is the value of sine pi by 3. Sir, root 3 by 2, sir. Sir, root 3 by 2. And this will become beta g. This will become, I hope this is clear to everyone. This will become root 3 and unit of position is meter. I hope you are enjoying the class beta. Next, that is the velocity as function of time. What is the meaning of this? Firstly, we have to understand the meaning. What is the function of time? Whenever such type of question is asked in whole physics beta, it means the question examiner interested to find out, can you develop a general relation? Yes or no? What is the meaning of general relation? That we want a relation in terms of variable. Okay, we does not want to you describe a specific relation. You want to develop a general relation. So general relation we just want in velocity. How we can find out the velocity if the displacement or position is given? Sir, just differentiate the equation. So if we differentiate this equation number 1, anybody beta in this class, what is the differentiation of this? This will become 2 into 2 pi, and differentiation of sine omega t plus theta is nothing but beta cos omega t plus theta. Okay beta, I hope by using basic mathematics we know that the differentiation of sine theta is the cos theta, and whatever term involved with variable we multiply with outside the differentiation. Just put outside the differentiation. That's why we put 2 pi multiply with 2. Okay, and this will equal to beta that 4 pi cos 2 pi t plus pi by 3. Okay, what is the next beta? Acceleration as function of time. Sir, again velocity is given and we have to find out acceleration as function of time. Then again we have to differentiate this, and we know that what is the differentiation of this, that this will equal to beta minus 8 pi square, and differentiation of cos theta is nothing but minus sine theta. That's why we put negative sign here, and this can be written as sine 2 pi t plus pi by 3. I hope this is clear to everyone. How we can proceed? What is the thought process we have to follow here? Okay, That next is the initial velocity. Sir, what is the meaning of initial? Sir, t equal to 0. It means we know the general equation. Yes, sir, we know this is our general equation. If we put t equal to 0 here, we will get value of initial velocity. Sir, this is very easy. Okay. And such type of question always excited to me is, sir, please solve such type of questions so that we make a crystal clear concept. And believe me, guys, such type of question, you just look the JEE Mains that is continuously going on. Such type of question that is asked in JEE Main. Simply any one part can be asked. Okay, so we must have a proper confidence in how we can tackle such type of problem. Once we have to find out the initial velocity, put t equal to 0 here, and this will nothing but 4 pi cos pi by 3, that is 1 by 2, and this value will become beta 2 pi and unit meter per second. In the same manner, if you want to find out the initial acceleration, see where is the general equation of acceleration. This is the general equation. Put t equal to 0 here, and in order to write down, if you want to write down only magnitude, no problem. If you want to write down with magnitude and direction, you can, beta. So this will equal to minus 8 pi y square sine pi by 3. Again, beta, this is the 3 by 2. If we solve this, this value will become 8 pi square. This will cancel out. So we can simply, if we solve this, after solving this, what we can write down here, beta, we can cancel out 2 with 8. And this value will equal to minus 4 pi square root 3. And unit is nothing but beta, that is meter per second square. So this is the basic approach to deal such type of problem, and all possible questions that can be asked in the kinematics of SHM, we ask here. Okay, what is the next, beta? Next problem, I will give homework to you and you have to solve by your own self. Okay, so this is the homework problem for you guys. So please take a screenshot. Or you want to write down this problem, you can write down. And I hope everybody can solve this problem, because this is nothing but just photocopy of the previous problem. Okay, so please ensure, if you can solve this problem, give me a thumbs up. If you can solve this problem better, give me a thumbs up. Come on, guys. So then we can move. Please give me a thumbs up, beta, because your thumbs up is acting like oxygen for me. Okay, so give me oxygen. Give me oxygen, beta. Come on. If you can understand each and every concept very clearly, you please give me a thumbs up, guys. Come on, guys. Write down this problem and try to solve as a homework problem. If you, I hope everybody can write down this problem, all the same parts that in the previous problem that is asked in this particular question. So we can say that we have to write down only this part, and these parts are portions are similar as previous one. Okay, so let's move for the next concept, beta. Our next concept that make SHM is very easy, and that is nothing but what is the projection of SHM in uniform circular motion. So firstly, we have to understand the meaning of what is the meaning of uniform circular motion. We just want to recall you, beta, whenever I want to call you uniform circular motion, what is meaning of this, beta? Anybody? Can you tell me, sir, what we understand by this word uniform circular motion? It means a particle will performing a circular motion with constant angular velocity. If the angular velocity of particle is constant, we can say this is the tangential velocity at any time t. And if particle is performing circular motion with a constant angular velocity where omega of particle is constant, or we can say that the speed of particle is constant. Such type of motion is known as uniform circular motion. In short, we can say UCM. And one important thing that we have to know here, in every uniform circular motion, the value of tangential acceleration is always 0. Why tangential acceleration is 0? Because tangential acceleration is nothing but beta r into alpha, and alpha is angular acceleration, and angular acceleration is nothing but rate change of angular velocity. As you already mentioned, sir, in uniform circular motion omega is constant. It means this quantity is constant. If this quantity is not going to be changed, then what is the change of omega with respect to time? You can say 0, sir. It means we can say, sir, here 80 is 0. So particle will performing circular motion and only centripetal acceleration motion is occur here. The net acceleration is nothing but that is the centripetal acceleration. The value of centripetal acceleration is always v square upon r, or omega square r, and that is always acting towards the center. I hope everybody is aware about this. Yes or no, guys? Everybody know about this basic concept about the uniform circular motion. These are the basic terms that I want that you should know how uniform circular motion is happen. Let's move for how SHM is projection of uniform circular motion. Just what I want to say you, just listen carefully, guys. We say that suppose a particle that performing a circular motion, if we consider a particle that performing a circular motion, this is the position of particle at t equal to 0, and particle is performing circular motion in clockwise direction. Okay, we can suppose, and suppose that in upper side, if we give a light to this particle, suppose if we fall a light from this side on the motion of particle, particle is moving in such a manner, you can say here how particle is moving. If you want to see that, you can clearly say the particle is moving in such a manner, t equal to 0, t equal to t1, t2, 3, 4, and so on. Our particle is moving in clockwise direction in such a manner. Can you feel it? Can you feel it? Yes or no, beta? Yes or no? And if we project a light from upward direction, what is meaning of this, beta? We want to take a projection of this particle, the particle which is performing uniform circular motion. We want to see what is the projection of this particle in the horizontal plane, in the horizontal line, beta. See clearly what we assume that our particle is performing clockwise circular motion where omega is constant. Are yes or no, beta? What is the radius where particle is performing circular motion? So that radius is nothing but this is the radius, that radius is t. See. If we project this particle at this point, okay. If our particle is at this point, what is the projection? This is the projection. If our particle is at this point, what is the projection? This point. If our particle is at this point, what is the projection? This is the projection. If our particle is this point, again this point. If our particle is this point, this point. If our particle is at this point, then projection is happen here. In such a manner, I can say that it is clear to everyone how our particle is moving and how its projection is also moving. If particle is moving in clockwise direction, we can say that the particle is moving in clockwise direction. So we can say what is the projection? This is the projection. Then our particle is moving in this direction. When particle is beta at this point, we can say the projection of particle is at this point. When particle is at this point, then projection of particle is this point. So it is very obvious how we can deal the simple harmonic motion. This is nothing but that is the projection of uniform circular motion. Please give me a thumbs up if everybody can understand the concept. It's a simple harmonic motion is nothing a very special thing. It's just a projection of uniform circular motion on a horizontal line. Please give me a thumbs up, beta. It is clear to everyone whatever I want to convey with you. Okay, beta. Sir. Are you taking any assumption? Yes. First assumption, uniform circular motion. What is meaning of this? Sir, omega constant. Omega constant. Okay. What is the second assumption? The radius of this circle is equal to this value, and this value is nothing but this is the amplitude. Okay. So amplitude is nothing but beta. Amplitude is radius of circle that particle is performing circular motion. That is A. Okay. What is the second? Our particle is moving in the clockwise sense. And if we consider at t equal to 0, our particle is at this position. So where is its position? At mean position. And after any time t, the angle made by this particle is theta. So what we can say here, we know that ki beta, omega is nothing but a rate change of angle, that is the theta upon t. So here we can say that theta equal to omega t. Theta equal to omega t. Okay, sir. If theta equal to omega t, so what we can say here? We can say here that this value is amplitude A. This value is, see here beta, this value is amplitude A. And we know that if this angle is theta, so this angle by alternate angle also theta. What is the component of this amplitude in horizontal direction? So this value is nothing but A sine theta. It means this value is nothing but beta. This value will equal to A sine theta. See here beta. This value is equal to A sine theta. This is nothing but this is the position of particle, displacement of particle at time t. What is the theta beta? Theta is omega t. So just put the value of theta. This is the omega t. So this is the position of particle. Okay, sir. Sir, another thing we want to name, what is the velocity of particle? If you want to know the velocity of particle, see here beta. If particle is moving in clockwise direction, so this is the tangent at this point. If we want to know the velocity, we know that this is velocity of particle. And how we can say that beta, this velocity of particle performing circular motion is always v equal to r omega. Okay, sir, I am agree with you. V equal to r omega. Okay, sir. So how we can write down here, sir? How we can write down here? Just see beta. Just see here. If we can say that this is our velocity vector, we can project this point at this point. What is, if this angle is theta, so we can say that this is total angle is 90, because this is the normal line, this is the tangent line. So this angle will become 90 minus theta. If we draw a horizontal line here, so this angle will become theta. So what is the component of velocity at horizontal direction beta? That is v cos theta. And what is the v? V equal to r omega. What is the r beta? That is the equal to amplitude. That is the omega a cos theta. Why we interested in horizontal direction? Because we know that our particle is performing to and fro motion. So we only interested the velocity component which is in horizontal direction. That is nothing but that is velocity of particle performing circular motion. That is, we can say that a omega cos theta, put the value of theta, that is the omega t. Okay. One important thing we have to know here, the initial position we consider that particle at t equal to 0. It means phi is 0 here. It means phi is 0 here. Suppose if particle start its motion from this point, then already particle makes some angle phi here. Okay, I hope this is clear to everyone. The second point, what is the acceleration? We know that this particle is performing circular motion and that is uniform. It means only one acceleration, that is the centripetal, that acting toward the center. And what is this component in the horizontal direction? This is the component of this acceleration in the horizontal direction. Sir, this is acting in this direction. Yes, because particle is moving in this direction, and that is the first condition of the SHM. And this is nothing but minus omega square a sine omega t. I hope you can understand what is SHM. That is nothing but projection of uniform circular motion. And you can feel that beta, we can solve a very tough problem by using uniform circular motion within second. Okay, let's see. Suppose a question is given, we just try to understand. write down, we have to write down the equation of SHM whose amplitude is A. Amplitude is A and the angular frequency is omega. Initial position is shown in figure. So what is given here, beta? We have to describe the position of particle here. The particle is moving in leftward direction at t equal to 0 and position of particle is x equal to 0. Then we have to write down the equation. How we can write down the equation? How we can initiate this problem? We just draw a circle so that we can form a uniform circular motion. And we know that at t equal to 0, what is our assumption? We can consider our particle is moving in clockwise direction. Okay. So at t equal to 0, what is the possible position of particle? We can say this is the value where x equal to 0. This is the value x equal to plus a. This is the value x equal to minus a. I hope this is clear to you. Okay. And particle is moving in leftward direction. So we start from this point. If particle is moving in clockwise direction, then direction of motion of particle is something like this. Okay. And particle is moving in leftward direction. Say this is to 0, because at x equal to 0 there are two possibilities. Either particle is at this point, either particle is at lowermost point. So which point we have to choose in here, beta? Because we have to see the direction of particle. Particle is moving leftward. So in this point, particle is moving in this direction. So this is not possible. So only this position is particle. It means at initial point our particle is here. So what is initial angle made by particle? So what is our reference point? This is our reference point. From this point we have to measure the angle. So we can say this is 90 and again 90. What is the total angle made by particle, beta? That is 180 degree. That is 180 degree. So what is phi here? 180 degree. So what is our equation, beta? Our equation is nothing but x equal to a sine omega t plus phi. We know that here initial phase angle is 180 degree, and we know that the sine 180 plus theta is nothing but beta. That is sine 180 plus theta. We can say that is the minus sine theta. I hope this is clear to everyone. So our equation will become sine omega t. X equal to minus a sine omega t. At the same time, if direction of particle is shown in rightward direction, then which point we have to choose, beta? That uppermost point. And uppermost point, what we have said that what is the initial phase angle from this line? What is the reference line? This is our reference line, beta. So we can say this angle is 0, so phi is 0. In that case, answer is a sine omega t. I hope this is clear. So if you can understand the previous concept, can you solve this problem? Can you solve this problem? What is answer of this problem, beta? Please tell me answer in the comment box. Please tell me answer in comment box. We have to write down the equation of motion. Come on. JNV Hyderabad, Rahul, Sujan, JNV Pune, please answer this question. What is answer? What is the equation of motion? If you can solve, you just give a thumbs up in the comment box. Just give a thumbs up in comment box. If you can solve this problem, send me a thumbs up, beta. Okay. How we can approach, sir? Just see where our particle at t equal to 0. Here the direction of particle is rightward direction, and this is our t equal to 0. Okay, sir. So what is equation of motion? How we can solve? We know that we just draw a uniform circular motion, and that amplitude of particle is described by the radius. So this is plus a, this is minus a. I hope this is clear. And our particle is nothing but at this position. Say this position is beta a by 2. Okay. What is assumption? Our particle is moving in clockwise direction. Okay, sir. Sir, at x equal to a by 2, there are two possibilities. If once our particle can be here, and our particle also, it is possibility our particle at lowermost point, at this point, that is not lowermost point, that is the projection. So at which point we have to choose here? We know that at this point the direction of velocity is here. At this point the direction of velocity somewhere here. Okay, and we know that our particle is moving in this direction. So we can say that this point is nothing but projection of this thing. Okay, so this is the correct position of the particle. Then what is the angle that made by particle? We can say that here we can easily measure this angle. This is the radius A, this distance is A by 2. So we can say that beta, if this angle is theta, so this angle we can say that this is theta. What is this angle theta? We can say for sine theta, that can be nothing but A by 2 divide over A. That is the A by 2. And this is nothing but beta. This is the value of theta equal to 30 degree. I hope this is clear. Then what is equation beta? That x equal to A sine omega t plus phi. What is phi here beta? What is the initial angle at t equal to 0 z particle is made? That is the 30 degree. This is our answer. This is our answer. I hope this is clear to everyone. Okay beta, let's solve this problem. Can you tell me what is the right answer of this problem? Here particle at t equal to 0 shown at minus a by root 2. So how we can draw this in the uniform circular motion? Okay, just write down this problem, and this is a homework problem to you guys. This is a homework problem to you guys. You have to solve this problem by homework, and you have to mention the correct answer in the next class. Okay, I hope you can take a screenshot of this problem. Okay, so let's move for the next question. Next article beta, that is what is energy in a system? As particle is also possess some speed, so we can say that the particle must have some kinetic energy. As earlier we discussed, because this is the second part of the stable equilibrium, it means particle must possess some potential energy. So what is the kinetic energy? Sir, if in dunya there is a mass, so mass having a tendency to store a possess a kinetic energy. Whenever a particle having mass and particle must having some speed, so how we can write down the kinetic energy of particle beta? Half mv square. Okay, sir. Sir, what is the speed of particle at any distance x? If our particle is performing SHM, this is x equal to 0, this is x equal to plus a, this is x equal to minus a. So if at any time t our particle displacement is nothing but x, and say the velocity of particle is v, so what is the velocity of particle as a function of x? We already know na, omega under root a square minus x square. Yes ya no beta? Yes ya no? So how we can write down the beta? Velocity that half m omega square, and this will equal to a square minus x square. This is nothing but kinetic energy of particle. We have to remember this formula. I hope this is nothing but just put the value of velocity in the equation of kinetic energy. And the same manner, if you want to write down the potential energy, how we can write down the potential energy? Everybody can write down the potential energy. How we can write down the potential energy? Just try to think better. We know that, sir, we know the equation of restoring force that F equal to minus times of Kx. And there is an important relationship for stable equilibrium, that how we can define the force, that is nothing but minus du upon dr. I hope this is clear to everyone. Yes, no beta, this is the important relationship between force, that is the conservative force, and that is with potential energy. Particle is moving in the x direction. We can say that this can be written as minus du upon dx. And in order to find out the potential energy, this value, if we put F equal to minus Kx here, beta, what we will get here? Just see, beta, just see. We can say that, sir, F equal to minus Kx and F equal to minus du upon dx. If we put minus Kx here, so this will become minus Kx and minus du upon dx. So this will become kx dx equal to du. Okay, sir. In order to calculate potential energy, we just integrate this beta. And how we can put the limit beta? We know that sir, listen, sir. At mean position, potential is minimum. And if we consider minimum potential energy is zero, so we can say that X equal to potential energy 0. We can assume potential energy as any value at a given point. There is no restriction. We already know that. Yes, you know, the change in potential energy importance and absolute value of potential energy, you can choose your own reference. Sir, at any distance x, if we assume that our potential energy is u, what is the integration of this? Sir, this is u. Sir, kx dx, k is SHM constant. Yes. Can we take outside? Why not? What is the integration of x dx? X square by 2. If we put this limit beta, so this will happen x square by 2. Oh my God, we will develop a very, very important relationship, that is the potential energy in SHM. Half k x square, half k x square. Arey yes, Yano beta. Sir, see here, x having power 2. Potential energy having power 1, and in dunya such type of graph which come into picture. This graph is nothing but parabola. Kya bola? Parabola. So what is the graph of potential energy, sir? If you want to develop graph of potential energy, tell me please, this is the, in place of y-axis potential energy, in place of x-axis, that is x. Sir, CCC, particle is performing SHM between stream position. So that is the x equal to plus a, that is x equal to minus a. This is x equal to 0. If we put x equal to 0 here, potential energy is 0. If we put x equal to plus a, potential energy is half k square. If we put minus a, again half k square. And we already know, sir, this is the graph of the parabola. So we can say that this graph is, see here, we are not so smooth in graph. So sorry for that, beta. That is, we can say that how we can draw parabola here, something like this. I hope this is clear to everyone. And this is the maximum value of potential energy, that is the half k square. Oh my God, that value will occur at stream position? Yes, sir. At stream position, maximum potential energy. At mean position, minimum potential energy. And graph is parabola upward. This graph is not going to be infinite. That is restricted between minus a to plus a. I hope this is clear. Yes or no? Yes or no, beta? Sir, at the same time, we want to draw the graph of kinetic energy versus x. Why not, beta? Sir, say, see. X having power 2, yes. Kinetic energy having power 1, yes. Whenever two variable is correlated in such a manner, one having get 2 chocolate, another having get only 1 chocolate, and such type of discrimination is occur between the variable, then always graph is parabola. What do you want to say, sir? If y equal to x square, x is giving 2 chocolate, y is giving only 1 chocolate. So discrimination is occur. Okay, sir. So we can say कि what we have to give sympathy? Y. Bechara y only getting 1 chocolate. So we have to make our parabola in y-axis. That is the concept you can keep in our mind. If x equal to y square, so who is bechara here? Who is bechara here? X only get 1 chocolate. So we have to make our parabola in x-axis. Okay, sir, this is very excellent concept we can apply it here. But one thing, sir, that parabola x square and having negative coefficient, that parabola, we can say parabola downward. Just put the value of x equal to 0 here. Sir, if we put x equal to 0 here, kinetic energy will become maximum. And this will become half m omega square a square. Okay, sir. If we put x equal to a, oh my God, if we put x equal to a, that will become 0. Again, if we put x equal to minus a, this will again equal to 0. अरे वो क्या रहा है सर? Okay, and x equal to 0, this will having maximum value. This is nothing but parabola downward. This is the graph of kinetic energy versus x. I hope this is clear to everyone. Please give me a thumbs up, guys. Please give me a thumbs up if you just gained whatever I discuss here, how we plot the graph of kinetic energy and potential energy. And I hope if you want to calculate total energy, just add kinetic energy with potential energy, you will get the value of total energy. So in next class, we discuss that some numerical problem that is based on the energy in SHM, and we discuss some important property of the spring block system, how we can find out the time period of spring block system, and some important point about the angular SHM. So I hope you enjoy this class. Thank you so much for attending the class. Okay, beta. So be happy, and we will meet again in next class.